The mystery of the Tunguska Event begins with a silence so vast that it seemed to swallow the Siberian wilderness whole. Then, in a single moment, the stillness was torn apart by an explosion so powerful that it reshaped the landscape and puzzled generations of scientists. It remains one of the most dramatic natural events in recorded history, yet more than a century later, its cause is still debated. This is the story of the largest atmospheric blast ever witnessed by humanity, and the question that refuses to fade. What exactly happened over Tunguska in 1908? The place was remote even by Siberian standards. Dense forests stretched for hundreds of miles, interrupted only by winding rivers and scattered camps of reindeer herders. On the morning of June 30th, 1908, the people who lived there noticed a bright glow rising in the sky. Those who were awake described it as a streak of light that cut across the heavens. Others said it looked like a piece of the sun breaking loose. Moments later, a shockwave ripped across the region with enough force to knock riders from their horses and shatter windows hundreds of miles away. In the small town of Vanavara, residents were thrown to the ground as a searing heatwave washed over them. Many thought the world was ending. Those who were far enough away to avoid injury described an energy unlike anything they had ever felt. A travelling merchant later recalled seeing the sky split open. Witnesses said that trees snapped like twigs. Some believed a great fire had erupted in the forest, one that produced no smoke and consumed everything in its path. But because the region was so inaccessible, no scientific team reached the area until nearly 2 decades later. When the expedition led by Leonid Kulik finally arrived in 1927, the team expected to find a crater of immense size. Instead, they found something altogether stranger. The blast zone stretched across more than 2,000 square kilometers. Trees were flattened in a radial pattern, their trunks pointing away from a central point like the spokes of a wheel. Yet at the core of the devastation, the trees remained standing but stripped of branches, as though a powerful shockwave had passed over them. There was no crater. There were no fragments of an object. It was as if something had exploded in mid-air, leaving only the imprint of its energy upon the forest below. This mystery would define the research that followed. Scientists compared the devastation to that of a powerful nuclear detonation, even though nuclear weapons would not exist for several decades. Later calculations suggested the blast may have been equivalent to at least 10 million tons of TNT. The power released was immense, but the source remained elusive. Kulik's team searched for physical evidence of a meteorite. They dug into peat bogs and sifted through the soil. They studied the pattern of the fallen trees, hoping it would lead them to a point of impact. But every attempt ended with the same result: no debris, no crater, and no clear answers. As the decades passed, theories multiplied. Many scientists concluded that a stony asteroid had entered the atmosphere at tremendous speed, heating up until it exploded several kilometers above Earth's surface. This explanation accounted for the flattened forest and the lack of a crater. It also matched eyewitness reports of a bright fireball. But the absence of meteorite fragments raised new questions. A body large enough to release that much energy would normally leave behind at least some detectable material. Geochemical surveys found traces of minerals that could have come from space, but the evidence was inconclusive. Others suggested that a comet, composed mostly of ice and dust, had disintegrated in the atmosphere, generating immense heat and pressure. A comet would leave even fewer traces than an asteroid. This idea gained traction because comet fragments encounter Earth regularly and often behave unpredictably. Yet even this hypothesis could not fully explain the precise pattern of the blast zone. As researchers debated, more unusual ideas surfaced. Some proposed that a fragment of antimatter had collided with the atmosphere and annihilated itself. Others suggested a tiny black hole passing through Earth, releasing energy as it entered and exited the planet. These ideas were speculative, unsupported by evidence, and considered highly improbable by most scientists, yet they reflected the enduring sense of mystery surrounding the event. Attempts to reconstruct the explosion through simulation brought new clarity. Modern models showed that an asteroid or comet fragment entering at a shallow angle could release its energy as an airburst 30 or 40 kilometers above the surface. The shockwave would spread outward, flattening trees in a radial pattern while leaving no crater. Later studies of other atmospheric explosions, including more recent meteor events, supported this theory. The famous Chelyabinsk event of 2013 provided real-world data. A smaller asteroid exploded over Russia, creating shockwaves that shattered windows and injured more than 1,000 people. The patterns of damage were strikingly similar to those observed at Tunguska, though on a far smaller scale. This comparison strengthened the case for an airburst. Yet even with new technology and modern examples, Tunguska still presents puzzles. The exact altitude of the explosion remains uncertain. The composition of the object has never been established, and the enormous scale of the blast challenges assumptions about how fragile objects behave as they enter the atmosphere. Moreover, Tunguska remains a singular event. No other recorded atmospheric explosion matches its magnitude. The sheer isolation of the site has also left room for speculation. Without photographs from the time, researchers rely on later expeditions and the testimonies of witnesses who lived in remote camps, far from written records. Some historians suggest that cultural interpretation shaped the accounts that followed. People described a blazing fireball in terms that matched their beliefs and traditions. This makes it difficult to reconstruct the event with precision. Yet despite the limitations, the essential truth remains clear. Something huge entered Earth's atmosphere that morning, releasing energy on a scale that challenges imagination. Understanding this event is not only a matter of scientific curiosity, it is also a reminder of the planetary risks that exist beyond human control. Today, space agencies track near-Earth objects with increasing accuracy. They model trajectories, estimate potential impacts, and develop strategies to deflect hazardous bodies. Tunguska stands as a reference point for what can happen when an object enters unnoticed. Midway through these investigations, many viewers seek deeper explorations of scientific mysteries, and if you enjoy stories like this, consider subscribing for more. Researchers continue to examine the region, analyzing soil samples, tree rings, and ancient sediments. These clues reveal the effects of sudden heat and shock on the local ecosystem. Some trees contain traces of chemical elements that hint at an extraterrestrial origin, though the evidence remains debated. In recent years, more sophisticated surveys have attempted to map the landscape in fine detail. These studies look for subtle depressions or anomalies that could indicate small impact sites. A few candidates have emerged, but none have been confirmed. Some teams have explored nearby lakes, hoping that a fragment might have plunged into the water. Lake Checo, a small body of water north of the epicenter, sparked interest when researchers proposed it could be an impact crater. But follow-up studies suggested the lake might be older than the Tunguska event or formed by natural processes unrelated to an impact. In this way, the evidence continues to oscillate, offering hints but no definitive solution. The absence of certainty has become part of the story itself. The Tunguska event sits at the intersection of geology, astrophysics, and human memory. It forces us to confront the limits of our knowledge about the objects that travel through space. It reminds us that Earth has experienced impacts far greater than this one in the distant past. Tunguska is modest compared to the ancient collisions that created mass extinctions, yet it is large enough to reveal what a smaller, more local catastrophe might look like. The blast flattened more than 80 million trees. The shockwave circled the globe twice. Atmospheric disturbances were recorded as far away as London. Night skies glowed for days because of particles scattered high in the atmosphere. This was a regional disaster, but its reach was global. If it had occurred over a populated area, the consequences would have been devastating. And yet, for all its power, the object responsible for the Tunguska event appears to have been small by astronomical standards. Some estimates suggest it may have measured less than 100 meters across. This scale is significant because it highlights a category of objects that are difficult to detect with current technology. Tiny compared to major asteroids, but still capable of causing catastrophic damage. In this way, Tunguska serves as a historical warning. The event also illustrates the challenge of interpreting natural phenomena without immediate scientific observation. For nearly 20 years, the blast zone remained untouched by researchers. During that time, the landscape shifted, trees decayed, and organic material broke down. By the time Kulik's team arrived, the scene they encountered was already transformed. They had only the ghost of the original event to study. Despite this, their work laid the foundation for modern impact science. Kulik's team documented the forest pattern in detail. They collected eyewitness accounts from local residents. They trudged through swamps and frozen terrain to find whatever evidence remained. While they found no meteorite, they helped establish the scale and characteristics of the blast. Their efforts eventually led to a broader understanding of how objects explode in the atmosphere. Later researchers expanded on this work using high-altitude observations, seismic data, and computational models. Each new approach added clarity, yet the core enigma persisted. Perhaps the most striking aspect of the Tunguska event is how it balances explanation and uncertainty. The general mechanism, a cosmic object causing an airburst, is widely accepted, but the details resist a definitive answer. Was it a stony asteroid? Was it a fragment of a comet? What precise trajectory did it follow? What altitude did it reach before exploding? These questions shape the ongoing research. Scientists continue to refine models that simulate atmospheric fragmentation. They study the heat signatures and pressure waves that accompany disintegrating objects. They compare Tunguska to other events, from ancient craters to modern meteor explosions. Each new discovery helps narrow the possibilities, but none has closed the case entirely. The mystery endures because the evidence is sparse and the event was singular. Tunguska sits at a point where the known and the unknown meet. It forces us to accept that some natural episodes leave an imprint too complex to decode fully. And yet, the pursuit continues, driven by the belief that even the most elusive phenomena can reveal their secrets with time. Today, the Tunguska region has returned to silence. Forests have regrown, covering the scars left by the blast. The landscape appears calm, offering no hint of the violence that once swept across it. But beneath the surface, traces of the event remain. They lie hidden in the soil, trapped in sediments, preserved in the patterns of new growth. They wait for the next team of researchers to uncover what generations before them could not. The Tunguska event invites us to reflect on humanity's relationship with the cosmos. It underscores the reality that Earth is part of a larger system, one shaped by forces beyond our control. It reminds us that the planet has always been vulnerable to impacts from space, and that vigilance is essential for understanding and mitigating future threats. Most of all, it challenges us to embrace the incomplete, to recognize that some mysteries unfold slowly, revealing themselves only through patience, curiosity, and persistence. The blast over Siberia was a moment of staggering power, yet it was also a moment of profound humility. It demonstrated how small we are in the face of cosmic events, and how much we still have to learn. The mystery behind Earth's most violent atmospheric explosion remains open, shaped by evidence that is compelling yet incomplete. It stands as one of the greatest puzzles of modern science, a reminder that even in a world defined by knowledge, some questions still reach beyond our grasp.